got a NEFF Washer Dryer machine that the drying cycle's not working. We have power, the lights come on, the drum runs, rotates, but there's no heat in the dryer, so the dryer circuit heater is not heating. So this can be the thermostat or the heating element. I'm just going to show you how to check the heating element with a multimeter. On the back here, I'm going to assume that you know how to remove the covers, because it is pretty straightforward, to be honest, so we're not going to go through removal and exposure of the covers. But before we take the controller out and have a look at the relays on the controller, that's the other part of the circuit which could cause us a problem. We're just going to check the heating elements themselves. Of course, make sure the thing is unplugged and not powered up, and do this at your own risk. So you need your multimeter set to the ohms range. Okay, and if we just probe across, these two connections here are the common, so these are connected together by a buzz bar, so that's one connection for your probe. And there are two heating elements inside here. I recommend you do not take this big lid off, because it is sealed with a lot of silicone all round, and unless you put that back with an adequate and really watertight seal or airtight seal, you get condensation inside the machine, because the steam, hot air, the moist air leaks out and condenses all over the controller and causes you problems. So don't take this off unless you have a good reason to. Okay, now as I say, this is the common connection, and these are the two connections. There are two heating elements in here. One is for gentle dry, and both of them is for intense dry, so it's basically they can vary the amount of heat that you're getting. So if I just put my probe on the first element there, and if you look across to the meter, you'll see you've got an ohmage of about 57 ohms. Alright, so that's correct. And then if we put on the other connection, which is the other heating element, we should have more or less the same. Yeah, we've got 56.3. Show the meter. Oh, you can. Okay, so yeah, that's okay. And the final thing is there should be no connection between there and ground. And I can see you've got 5 mega ohms, 5 million ohms there, so there's no short. And in fact, if there was a breakdown inside the heating element between the actual heating conductor and the metal case of the heating element, which is grounded, then it'll probably throw out your RCD, current breaker, or blow the fuse in the plug, depending on what sort of wiring you've got in your house. All right. So to me, that heating element looks okay. The resistance checks out okay, and there's no, 5 mega ohms is just general leakage. It's not. If there was a short there, it would be a few kilo ohms or 100 ohms or even 1 ohm. It would have other severe effects on your main supply, the fuse box and everything else, if there was a short inside those heaters. So I think those heaters are okay. Now, when we power it up and go through the drying cycle with the lid off, obviously don't touch anything, but what's happening here is that the motor is running, the fan motor is running. So we have the dryer fan impeller motor, which is this one, is running okay, and it's blowing the air through, but the thing is not getting hot. Not getting hot at all, not even the slightest indication of any heat, otherwise the machine seems to be working. Now if we look down in this section here, you can, if I turn this machine round, can you see in there's enough light? Yep. Yeah, it's all clear. There is a thermostat, this is the temperature sensor in the drying channel. It's a hot air temperature sensor, and you can see it just pushes into a rubber bung, and you can pull it out and unplug it. Alright, so it's probably about, what would you say, 20 degrees in here?
16, 17.
17, okay. 17 degrees, so we're just going to do a quick resistance check on this to see whether this thermostat has gone open circuit. Clearly, if the thermostat is giving a wrong reading, then the dryer will automatically assume that the heaters are okay. You can see 9.92 kilo ohms, and as it's on my hand you can see the resistance reducing. It's a negative temperature coefficient thermistor. Right, so at body temperature it should read something like 9.5 kilo ohms. So it appears to be working at the moment. So let's go on to the next thing. Okay, so we'll just slot that back into position. That seems to be working at the moment. It's not the thermistor as far as we can tell. It's not open circuit, and it is changing when it warms up in your hand. Push it back in. Alright, okay, so what's the next thing? You take the controller out, and to get the controller out you need to get the front panel off. To get this front panel off you need to take these 4 screws out of the front. 1, 2, 3. They look like that. Okay, put them somewhere safe. Now the panel will come away slightly, but there are some clips which you need to push down, so you need a normal flat bladed screwdriver. I'll cut this bit out. Bladed screwdriver, that's magic. Push down. And there are clips down along this front edge. If I point down here, can you see? Point down here, there is these clips along the front edge of the controller, hooking on to the return in the front panel metalwork, and you need to raise those up to push them over the top of this ledge here. There they are. And then you can see, if you stand up, you can see the contents of the front panel are revealed. Now we have got a bit of a wiring issue on this one. Look, this plug has, the keep cover has come off. You can see the internal crimped IDC insulation displacement connectors in there, but I don't think that's going to be causing an issue, but it's not quite correct, so we need to put that back. Now, word of warning about this, and I've learnt this from bitter experience, so I look after a few of these machines, is these plugs all along here, you can see them all, various plugs that plug into the controller. Unfortunately, the first time I did this, I didn't check to see which plug went where. Normally they're keyed and they can't go in the wrong place, and you just work it out and you just put them back. But my warning to you is these can be transposed and it's not clear where they go. So take a really good photograph of where these go and have a think about where they go back before you take this apart and remove these connectors, because you will regret it. So word of warning. Alright, the power connectors are okay, it's really just these ones along the front, in particular these and those. Now, so to get this unit out, you have to unplug all these plugs. It's not really very easy to get these connectors out down here without taking the actual controller off the panel. So actually the front control knob is captive in this panel and just slots into the power switch, which is in there. So just by removing these screws, we should be able to, this is a T20, is it?
Yep.
T20 Torx bit. Quickly remove these screws. There are long ones, there are short ones. Are there any more? Screws in the windowsill. Just going to take that. It's just on a peg which needs to be levered off. Not breaking. There we go. So the front panel will come loose. You can put that down, and the controller is revealed. I'll just have a quick look at the controller. It looks to me like someone has done something before, because look at all this graffiti on it, as though someone's been trying to work out what does what. Okay. You can see this dust around. It's not plugged in, is it? Right. See this dust around here? See that dust and that dirt? That is some dust from the dryer, the air that's being blown through, that's collecting around the high voltage areas of the circuitry. So that's not painted on, that's actually dust. This electrostatic force of the track is attracting the dust. And you need to clean that dust off when you're in here, because eventually it will alk across and cause a problem. So this is the area we're looking at. Someone's had a go at this already. It must be a repaired controller or something. I haven't done all this graffiti work on it, but have a look at the back of the bend of the relays and look at the solder connections and just see if you can see any solder connections which are hot or arced. Can you get a close-up of that on macro mode or something?
Pretty close.
There you go, you're looking at these joints around the relays. I'm not quite sure at the moment which one is the drying heater relay, but we'll find out. And just look to make sure that there aren't any scorched or burnt connections which need resoldering. It's very common for these kinds of connections on circuit boards, especially single-sided circuit boards, to not be soldered properly in production and then subsequently fail in use after a period of time. But it looks more or less okay as far as I can tell, I think. Yeah, it does. So the question is, why isn't there any power to our relays? So the first thing to do is to unplug all these plugs.
Having taken a photo.
Having taken a photo. Yeah, do not unplug these unless you've taken a photo first, because it will end in tears. Okay, inspect the edges of the boards as well to see that there's no burnt or discoloured or water damage. Quite often this lid will leak and it blows steam basically into this area, and then steam gets in here and causes corrosion and the power supply to blow up. So a steam leak there will cause the controller to fail. So in the back of the unit we've got more power plugs which need to be gently eased out. Inspect the spades for any scorching or burning or overheating. They get black, discoloured. Same with the insulation on these wires where they go into the plugs. They are quite difficult to get out. Sometimes you have to resort to give them a bit of a lever out like that. Okay, it's much easier than pulling on the wires. Now this one's interesting. This seems to be much tighter than it should be, which suggests, we'll find out and see, but if you do feel these are a bit tighter than they should be, they may have welded themselves onto the contacts, but usually there would be some signs of burning on the outside. Now that's not normal. Can't actually see any signs of overheating except that this pin here has turned brown down the corner, so it might be we've got an overheating issue. No indication on the board either, maybe it's just stuck, we'll find out. Yeah, and I think I'll have to get some pliers on that and give that a bit of a pull before we damage the crimps and connections. Okay, it's just very tight. And then finally this is where the mains goes in. This is the mains feed from the plug. Again, that's just a pull fit. One more connection down this end. And then we have the controller being removed. Should take over. I don't know why you can see. I can't see what you can see. You're in there. Now what we've got is this black powder, carbon powder, built up on the actual controller around the high voltage part of the circuit, which is not good. So I'm just going to use a dry toothbrush and remove it. Okay, so that side we can clean. So we've cleaned the carbon off that side. Now if we look on the other side, this is the usual suspect device down in here, the TNY 26 something or other N. It's the buck regulated power supply chip that runs at high voltage that produces a DC low voltage to drive the electronics. And again, you can see all this dust has built up all around here and around the coils and connections on the buck transformer, okay, all the way into here. So we're just going to remove this dust, give it a better chance. If that gets some condensation in your machine, that dust will then form a conductive path which could cause you a problem. So just get rid of it if you can. So wise move. While you're in there, give her a quick clean. Okay. Alright, so we looked at the controller and we've just buzzed all the wires through from here. So we went onto the live connection for this, which is on there, and then checked all the connections at the front. We couldn't find a connection, so then we stood back and had a good think. What else could be causing this issue? We're going to clean this controller anyway, because that carbon buildup is not good and it will cause it to fail eventually. Now, we've been looking at the temperature sensor, and we have just noticed this device down here. Now that you've had a necessary tour through the insides of the machine, you can see that there is a red button on this thermal trip. So I'll just test it, and you can see the thermal trip has tripped out. Okay, now we will then have to ask the question, why is it tripped? You could put this all back together and then it would work for a while and probably trip again. So we need to find patient zero, the root cause of this tripping. If I just push the button in and now try it, we have a connection. So the thermal trip has tripped inside the machine because this cavity is overheated, and what causes this to overheat is a blockage somewhere in the circulation system. Now if we look down around to the back of the machine, if I just pull that machine out, you can see that there is this condenser here. This condenser module has a cold water feed, cold water running into the condenser, air blowing through, goes up through the fan at the top, through the heating chamber we looked at, and then into the machine. So it recirculates around the machine, and the job of this is to remove the moisture from the air by keeping it cool. Now you can see that this is blocked up pretty much. I think if we take this off and clean it, this is the component which is supposed to be cleaned during the, what's it called, the Fluff cleaning cycle. There's a Fluff cleaning on cycle on this machine with every, do you know how many operations did it say?
Less than 10, I think.
Every 10 or less drying cycles, you have to run a separate cycle with nothing in the machine, which is intended to wash this out. And if you don't do that, and even if you do that, I don't know, I've always suspected the tenants don't bother, but it might be the case that it just is a feature of the machine, that this has to come out and be cleaned. Now, I don't know, can you see down under there? Can you see under there?
Yep.
You can see we've got a big rubber joining connector, what do you want to call it, a boot if you like, a boot, yeah, which needs to come off there, which you unscrew, so that will release the lower half. Yeah, so what it is I've taken the screws out of this, but you can't really get this off completely because you have to remove this solenoid block assembly, and you can do that, but it's fiddly getting it back because they all push into O-rings which then feed the water inlet tray. So, but by taking these out, you can just lift this up slightly by an inch or two, and you can see that the underside of this plastic trombone assembly, the condenser, is just a push fit on the base of the fan. Alright, now the screws here, were they holding the back on, or did you just take those out?
They weren't holding the back on. They were just holding that plastic tank in.
Okay, so the plastic tank screws which hold the plastic tank are here and here. There's two screws, this one and that one. You can see, when I move it, you can see the tank. You can see that the actual water feed pipe has already come off because I've lifted it, so remember that to put that back on. And then undo the T20 rubber concertina boot assembly from the main part of the drum. Okay, now be aware that some water may come out. We might need to go and grab a towel, so get your running shoes on. Or a bowl. Yeah.
It's one in the oven.
Use this one.
Yeah.
I'm not sure how much is there, if there is in there. Where's the cereal bowls and stuff?
No, probably.
Right, okay, take two. Put a cereal bowl under there. Oh, actually there's not very much at all. But you can already see the amount of detritus and stuff that's built up in this, look. Some part of a, possibly, forensic examination is required, but it could be a pair of knickers, that, compact. Right. Now where the other, what heaven's name is still holding this on? I do not want to take that fan out, particularly. There must be something down here as well. Yeah, a bracket there, look. Oh, I see. So this bracket here slots into the base of the unit to hold it. So you have to remove and slide this bracket down. It locks in a tab there, and that's made it better. And I think that might come out now. Okay. So it's free. It's come off the fan. We can just about without removing the whole thing. Do you think you can pull the drum that way?
The drum?
Yeah.
Yep.
Get hold of that. Yeah. We'll just trap your fingers, that'll turn. There you go. And this is what's wrong. This is what's wrong. That is pretty blocked up. You can see that there. And I think as well that probably the impeller on the fan, I'm just going to have a quick feel in here. The ones I've done before, the impeller is completely blocked up with fluff as well, so we need to get a quick look with the camera in there and see. But first of all, the job is to tidy all this fluff and detritus out of this thing. Okay, so we're going to clean this out and we'll come back to you. So this is the view of the underside of the impeller, the fan that drives the air through the drying circuit. You can see it's pretty awful, but it's not as bad as I've seen them, and to take it out would be a lot of fuss, so we just removed all the detritus around the outside edge. So we've unpicked all the fluff in there, in the sink and in the bin. We used a normal washing pad, you know, one of those things, and it was quite, all this detritus was quite stuck on, so I used a flexible plastic spatula to keep pushing this through, because it's quite narrow down there, and pushing it through and moving it around, sloshing it about to get rid of all the detritus. Okay, so that's that done. The actual condenser channel is clean, so let's put that to one side at the moment. Let's go and check the fan. We're going to put this back in. It's the reverse operation to how we took it out. Remember this rubber seal, it's easy if you sit this rubber seal on the top and then that pushes onto the base of the fan unit. I've shown you a photograph of the inside of the fan. It's pretty awful, but it's not that bad. The other ones I've done, the fan is completely blocked, but it looks like the blades are more or less free on this fan. Hopefully now that we've got some airflow there, the cleaning process will help to loosen off some of that fluff. It is a pain because if you take this lid off here, can you show us? If you take this cover off, you must make sure that you seal it very well, otherwise it leads to issues with condensation inside the machine. Right, so the reverse operation is going to be to lift this lid, push the drum across and slide this back up, but we can't do that on camera because I need the cameraman's spare hand to pull the drum over. So we carefully manoeuvre the condensation chamber back in place, or the air channel, or we want to call it, and lift this up, and then what you need to do is to make sure that rubber seal is not fallen off. So feel around the top of the fan where the condensation chamber meets the fan, round the front, and a quick reach around the back, to make sure that it's actually sitting, that you've got an airtight seal, and then holding this up, pop one of the screws in to start with. There's a screw here, and remember that bracket underneath? We've got a bracket down here, which I'm going to do in a moment. First of all, I'm just going to get this rubber seal over we're going to put this back onto here to connect the air channel back to the base of the machine. Can't feel any other pairs of socks or knickers or anything else lurking around inside there, so let's just put that back on. So that's the position of the plugs. Make sure you get it right. Some you can't plug in wrong, others you can.
You plug them in without the white plates.
Okay. Okay, so it's all done, it's working. You can feel that it's working because this gets hot. It's almost too hot to touch that. We've got the 52 degrees, something like that, or even possibly a bit more. The fan is running, the condenser is back in position, the screws are back, and you can see it's all clean and free of fluff now, so it will do its condensing. The mystery thing we found in there, in the stuffed up the dryer, inside the machine, was this. And it's actually, do you know what, is that a face mask?
Midget underpants.
Isn't that part of a bra cup or something?
That's a fake. That's one of those ear hook face masks.
Is it? Anyway, so that was what was plugging up the hole. And of course, we could have just reset the reset, but if you reset the reset and then put it all back together again, it's going to fail again because you have to remove the root cause of the blockage. And the root cause of the blockage was this was blocked with fluff. So that concludes the repair. Hope you enjoyed that. Any questions, let me know. And if you're repairing yours, good luck. Oh, and leave me a like and subscribe down there in the bottom of the screen. That'd be great. Thank you.